Hey everyone, Tom Cherry Holmes here with the FujiNet project, and one last video here for the weekend before I actually have to go do other stuff. But I wanted to show how HTTP posts requests actually can be done over SIO and how the SIO handler is going to actually be utilizing these. To do this particular test, we're actually going to be using a particular web service that's available specifically for testing such requests, making sure that HTTP clients work as they're supposed to, etc., called Postman Echo. It's a web version of the popular Postman program that you can have running in browsers like Firefox, Mozilla or Chrome, etc. But it's web-based here, so it's very well suited for our purposes. As we can see here, there are a number of different request types that you can use, and the one that we're really interested in are the post requests. Of course, we can send raw data as part of a post here, but we can also take and send in form data in a number of multiple formats. And for this, we're actually going to do essentially this particular example here, sending across two encoded form values in application XWW form URL encoded format. In order for us to do that, we actually have to set the content type for our header, and then we can pass in the then we can actually do the post request and read back the response. And again, as with all of the other examples I've shown you, I'm using the exact same test programs which just use the basic read and write SIO commands along with the header toggle that you've previously seen before in order to specify when to send headers, when to not send headers. So with that, let's go ahead and turn on the Atari here. We see our Atari in here, booted up to FujiNet config. We already have it set up so that we have our testing environment in drive 1 with the test programs in drive 2. So we go ahead and boot up OSA Plus. And we see, there we go, ready to go. We go ahead and open an HTTP request. Now, for the sake of brevity, I'm going to use HTTP and not HTTPS. But this works just fine over HTTPS too. HTTP. We're going to send to postmanecho.com/post on port 80. And we're going to use an aux1 value of 13, which means post. And we're going to translate line feeds to EOLs and back again. Okay, this particular request is now open, and at this point I can turn on the header toggle real quick. We haven't sent the request yet because we still need to take and send. We need to set some headers. In this case, we're using InWrite to InWrite to set a header that we want to explicitly use. In this case, we want to use content type. Headers are sent in the following format with the key on the left-hand side and the value on the right-hand side separated by a colon. Currently, there is no space. I'm deliberating on whether or not to parse if you put a space in here or not. But for now, we go ahead, application. We set the particular MIME type for an encoded piece of form data. And we send that across. That header is now set. We then say we don't want to use headers anymore. And then we can actually write our body data. Now, form encoded data, of course. If you've seen this, great. I'm not really going to explain it here. Key value, key value. Separated by ands, and of course, since it's URL encoded, percents for special characters, ampersands for special characters, etc. So, with that, press enter, and we will see within a few moments the request will be sent off. And if we actually do an end status at this particular point in time, we'll see that we get some data back. Look at this. Okay, so we see a 0C8, which corresponds to 200, and we get 18B bytes back. Let's start reading some of the data. This is now our response. And the data that we get back is in JSON format. Now notice here, if you look, you can see the data comes back, the args data, the form values, form bar, foo1 bar 1, foo2 bar 2, those get passed back just fine. We get some other information about the headers that we also send back, but they're also part of our JSON, our object, just because Postman sent it back in this form. And at this point, we can do a status again to see how many bytes we have left, which if I check in my handy dandy calculator here, since I don't trust myself, 139 bytes left. So, and there's the rest of our post. Done. Ready to go. And you can see right there we have a user agent value of ESP32HTTP client. Now, of course, we can set that going back using the end header toggle to whatever we want, but this is what gets sent back by default. So there we go. Our data, our JSON, everything nice and neat, sent back just as we want it, all from a post request. Finally, we can close the connection. So just as you saw yesterday with GET requests, the same exact idioms also apply to POST requests. With POST requests, you write out your query using nwrite, and then you can receive the response back with a read. Now again, these are test programs, and so the SIO handler will be doing this. So you would be using the equivalent of print statements, input statements, get, put, etc. But since I'm still debugging the SIO layer, I'm making sure that all of this works at the SIO layer before I write the CIO handler. So with that, I'm going to go ahead and end this particular video. I just wanted to go ahead and get this out real quick so you guys could see. As always, until next time, have fun.